Hello, everybody. We're back again with another screencast on object-oriented programming in R. We are still working on generic function, object-oriented programming, but we've passed now from the overview to the idea of doing your own things in generic function, object-oriented programming. We're going to look at writing your own methods for generic functions that already exist. And this is going to be something that you do more and more as you advance in your R programming skills. You're going to gradually transition from writing programs to help you accomplish your own task to writing programs that help other people who are maybe not as proficient in R programming as you are to get some of their work done easily and conveniently. And casual users of R do become accustomed to generic functions as things that might provide useful information to them about all types of R objects. And so they're going to be trying them out. And if you can write some methods for one of these common generic functions having to do with programs that you write, then they can leverage that programming without even really knowing that you're helping them out, which is kind of pretty cool. So we'll try some method writing in this section. We need something to work on, something where we've already got a pretty good grip. And so I'd suggest looking at section 6.6 from way back in the first semester on simulation, where we were looking at a problem of estimating the expected number of uniform random numbers you have to create until their sum exceeds a specified target number. So let's open this link in a new tab and give it a try. Just a little review here. So the scenario we wanted to have the simulation was this. Say that you're going to pick a real number between 0 and 1 at random, call it x1, and maybe you store it somewhere. And then you pick another real number, x2, at random. It's also any real number between 0 and 1, equally likely. And you add that on to x1. And then you check on that sum, x1 plus x2, and if it exceeds 1, then you stop. 1 is your target number here. You're going to keep adding on random real numbers between 0 and 1 until the sum exceeds that target number of 1. So if you haven't exceeded yet, then you pick a random real number between 0 and 1, call it x3, add it to the previous 2, and if that sum exceeds 1, then you'll stop, and if not, you pick a fourth real number, and so on. And you go in this way until the sum of the numbers you've picked exceeds your target number of 1. And there's a random variable associated with this chance process. It's the number of numbers you have to pick to make sure that their sum exceeds 1. So we'll call this random variable x. And, x could be as little as 2, but it might be 3, or it might take 4 numbers, or it might take even more, depending on how small the numbers that you pick end up being. And so what we did was we wrote a little helper function to just get us the idea of modeling, trying out this random process just once. And it was called the number needed function. And the idea is that when you start off, your sum currently is 0, and you haven't picked any numbers yet. But while your sum is less than 1, you're going to pick a random number between 0 and 1, just one of them here, call it number, and you'll increase my sum by the number. You'll increase the count by 1. And if the verbose parameter has been set to true, then you'll talk to the console at the moment and just say what you just picked and how many numbers you've picked so far and what their sum is so far. And when you get out of the while loop, which is down here, then your count will reflect how many numbers you had to pick, and that's what gets returned by this function. And so like if you were to try this function out, then you might get results like this, where it turned out to take 3 numbers to get the sum to exceed 1. And so here's the 3 returned down here. So if you want to estimate the expected value of x, then you know that you would have to repeat that process a lot of times, you know. And we eventually got around to just writing a function that would do this repetition for us, and it was called number needed sim. And it was a little bit generalized from the function we've written previously. In number needed sim, the user gets to pick their target number, although by default it's 1. And of course, they want to pick how many times to simulate the random process. Default is 1,000. They get to set a random seed if they want, and if they want a fancy report out to the console at the end, they could get it too. And the simulation proceeds in kind of in a way that you're familiar with from last semester. Here we are defining a new number needed function that's lets you choose any target you like. And then when we are in the simulations themselves, we're setting up a little results vector called needed, and that's going to hold the counts. And then for I and 1 to reps, we're going to run the number needed process on the target specified by the user and store the resulting count in the ith place of our results vector. If the user wants a report, there's going to be a table of the results that's reported out. But one way or another, the estimate of the expected value, the mean of the results vector, is going to be returned to the user, but it'll be returned invisibly. And that way it doesn't get in the way of the table and add extra stuff that is not really needed for the console. And so if you try it out, where say your target is 1 and you use a lot of reps and you ask for a report, then the report here estimates that the expected number needed is about 2.72. And in fact, it's a math fact that the expected number needed is exactly E, which is about 2.71828, which is kind of neat. So that was the number needed problem, and we're going to just fancy that up a little bit here. So first of all, we're going to rewrite number needed sim just a little bit. It's still got a target parameter and a reps parameter and a seed parameter, but you'll notice it doesn't have a report parameter. We handle the seed in the usual way. And we define a little helper function, number needed, inside and in the usual way. And we set up a results vector in the usual way. We record results into the results vector with a for loop in the usual way. But here's what is new. We construct a list out of the target number that is provided by the user and the counts for the numbers that were needed in our simulations. We make a list out of that. 2 elements, the names are target and sims. And we then assign a class to that list. We say that the class of the list shall be number needed sims. And then that list that has had this class attribute provided to it is what's going to be returned by the function. So, no report parameter that gives the option for providing a table. So nothing gets catted out to the console. just this list is going to be returned. Okay? So let's think a little bit more about what is going to happen out of this. Sorry, I'm having to change rooms. Was unexpectedly tossed out of the room where I was trying to screencast. Now, our next step is going to be to write a method function for the generic print function that will allow the print function to act specifically on things that are of the class num_needed_sims, that class that we've provided for that list we're planning to return. So it's a function of x. And the expectation is that x is going to be a list of class num_needed_sims. And this appears to be some kind of a reporting function that's catting stuff out to the screen. The target was whatever the target was in the list. And we're saying sims is the sims element of the x vector. Just to make it a little bit easier to talk about, how many reps we did must be the length of sims. And we're catting out a little table of the proportion of times that the count was, 2, 3, 4, and so on. That's this prop table here. That is the tab. We're going to eventually get that out to the console. There's a little bit of kung fu down here to make the table look a little prettier, to remove a kind of technical name that would appear at the top of the table if we were to just print it out right away. And so we delay printing out the table until we've removed that name, and then we print it out. And then we give ourselves a nice blank line, and then we give the report on the estimate of the expected value. Okay, so that's going to be our print method. And so I'm just going to head back to a little RStudio here, where I've got, as you can see, the num_needed_sim and that print method function in my global environment. And what I did was I just checked in the console. I ran, here I am getting up to where I was in the console. I ran method, quote, print, asking for all the methods that the print function now knows about. And if you search down through that big character vector that gets printed out to the console, it can be done because it's in alphabetical order. You will see eventually, where is N in the alphabet? Here in the 124th place, print.num_needed_sims. So that is now a known method for this print function. Okay. Now another generic function I'd like to address is the plot function. I'd like to give it a method for handling things of classes num_needed_sims. What I'd like is to call up ggplot2 because it produces pretty graphics, and make a bar graph of the results of the simulations. So plot.num_needed_sims shall be a function of x. And again, the expectation is x is that list of the target in the sims that gets returned by our num_needed_sims function. Now we're planning to use ggplot2, and who knows if the user's got it even, installed, much less loaded. And so here's a nice way to check in R whether a package has been attached to the search path. If package 1:ggplot2 in search path, if that is not true, then you cat out a message to the user that you're going to need to load that package in order to print. And really, I think you should probably say return cat, because if you go on, there's going to be a problem. There'll be a little error that's reported about having no ggplot2. I should probably fix that in the text. But if you get past this and it's all loaded, then again you set up your sims off of that list. And the work here is just to make a bar graph. And so I won't review ggplot too heavily here. Let's just see how it would work to give this a try. So like say you just ran number needed sim. Reps is 10,000, you give it a seed. Remember that when you run something top level, the print function gets called implicitly on the results of this expression here. So that print.numberNeededSim is going to end up being called to deal with the results, and you get exactly the report that you programmed into that method function, a report of the target, a little table of the proportion of times that it took 2 numbers, the proportion of times it took 3 numbers, and so on, and a report of the estimated expected value, so on average about 2.72 times. So that's the print method function being used. Another nice thing that you can do if you want to sort of address your results in different ways is to just go ahead and store numNeededSim into a results vector, and then you have these results that you can use in various ways, just as that list, because results is that list with these 2 elements. And so like if you needed just the target in subsequent programming, well, then you could get it, And if you wanted the printout later on, you could get it, because just evaluating results at top level calls the print on results, but result is that list of that class, and so you get the desired printout. And maybe you want to plot later on at some point. So you say plot results, and the plot.numNeededSim method gets called up and gives you this cool bar graph that talks about how in 10,000 tries, about half the time you needed 2 numbers, and about a third of the time you needed 3 numbers, and so on. So that's a look into how you can write your own methods for generic functions that already exist in R, like print, plot, summary, and there's quite a number of other ones. Next time we'll look into writing your own generic functions, the last exciting topic in our journey through object-oriented programming in R.